Hi everyone, my name is Maurice. I'm 14 years old, and recently I've been looking into AI, specifically facial recognition, SOC. So, I just want to start off by taking attendance of everyone who's here real quick. So, is Kim here? Great.
Here.
Is Jacob here? Present. Great. Is Michelle here? He's not here. I thought I saw him earlier. Okay, wait. Did any of you guys see him in the bathroom?
Who?
Michelle?
Oh, no.
No? I'll come back to him later. Does anyone see a problem here? A problem? Anyone?
Very slow.
Attendance. Okay. It's an unnecessarily long, archaic process that interferes with the development of youth, right? So let's just take high school, for example. Okay. A quick survey of my school showed that the median attendance time was actually 5 minutes per class. And this doesn't account for edge cases like supply teachers, like technical difficulties. So if attendance takes 5 minutes per class, and there are 4 classes per day, and there are 195 days of high school every year, that's 65 hours high school students spend on attendance every year. And if there are 4 years of high school, that's 260 hours spent waiting for your moment to say here. Imagine what students can do with all this time, right? This would mean, students covering, teachers covering their material in greater depth, students having more support available to them, more work time, etc., right? But wait, there's more. Because if we save just 120 hours of the 260 hours our attendance process takes right now, high school students can actually take 1 extra course in their high school careers. I know, it's crazy. But here's where the cool part comes in, right? So when I say go, we're all gonna snap our hands like Thanos, and this time's gonna go away. So 3, 2, 1. Introducing the Facenator. It's an AI-powered system that automatically takes attendance. So with the Facenator, basically students just enter the classroom, stop by this machine, check in with their face, and then proceed to class. Like a couple of seconds, super quick. So I have a video of my prototype that I created.
You might have to press play on the computer.
And now this is the file location where the attendance, once the program has completed, will appear as a spreadsheet, and we will see everyone who has checked themselves in and is present. So let's see this in action. This is our program. I'm going to run it real quick. You can see it pops up, camera. Now let's assume I'm the only person that appears. I come in to check into class real quick. You can see the squares there to say I've checked in. Then I move on to sit in my seat. And then at the end, the teacher comes, closes the program, and so we see the spreadsheet of attendance has appeared. If we open this, we can see it accurately displays attendance.
Wow, you should give this a TKS. Like, we need this.
Yeah, don't forget to like, comment, subscribe. So that was the cool fancy front end. Now I'll just talk a bit about the back end. And there's 4 main steps that go into it. So first, every student, before the event even begins, class or any other event begins, everyone submits a relatively clear picture of themselves. And this could be, for example, in schools, if we take that context, it could be like a school photo day, right? So these pictures can easily be found. And then that picture is basically used, an encoding is made of that picture, and then that's used to create a database, and there's names corresponding to encodings. So that's all done before the event even starts. And then step 2 is, when the event starts and people are checking themselves in, the Facenator takes the face in front of it and generates an encoding from that. Similar to step 1, except this is done in real time. So now step 3, once it has the database of all the encodings and the encoding of the face in front of it, it just does like a mismatch process, right? It looks at which encodings fit or are similar to each other, and once it finds an encoding that is relatively similar, it's like, okay, I found a match. And also in this process, there's a contingency clause actually So the Facenator needs to find a face and identify it for 3 frames before it marks the person as present. And this is because we don't want it to misidentify a face for 1 second and then the attendance is messed up because of that slight glitch or whatnot. And then finally, last step is just updating the spreadsheet. It's done all the hard work, and then it just updates the spreadsheet. And you'll notice during all these steps, I kind of mentioned encodings. And encodings are basically like what the computer can comprehend, right? So they're a string of numbers because the computer can't comprehend visuals, faces, stuff like that, right? So for example, an encoding of my face might be like 1, 2, 3, whereas encoding of a Mars face might be 4, 5, 6, just based on the different features. In reality, they're way longer to account for accuracy. And in this case specifically, I used the dlib library while I coded it. And basically what the dlib library does to get these encodings is it upscales an image to get more detail, and then it uses convolutional neural networks to scan it and create an encoding. So with that being said, it's time for attendance to take its permanent absence.